Hi, welcome back. Our previous lesson was on deriving the indifference curve. Today we'll be moving on to marginal rate of substitution, which is the slope of the indifference curve. We saw from our previous lesson that the indifference curve slope downwards, which simply means that if you decrease the quantity of one good to stay on the same indifference curve, you have to increase the quantity of the other good, implying a negative relationship. So what we saw in our previous lesson was an indifference curve shaped this way, which represents a trade-off between a particular good X and a good Y. If you start from a point here, say point A, if I take some of good Y away from you to be on the same indifference curve, I have to give you some of good X, which will move you to another point, for example, point B. So if indifference curve were not shaped downwards and they were shaped upwards, it will violate the non-cessation assumption that we've looked at in our previous lessons. So to see this, let's consider this figure here, where we have bowls of rice on the vertical axis and bowls of pasta on the horizontal axis. Still looking at our consumer named Ella. Now, 2 points represent two bundles and are marked on this indifference curve. So we have U1, which has bundle M and then bundle N, and then this indifference curve is upward sloping. So what we're going to show here is this is going to violate the non-cessation assumption. Bundle M has 5 bowls of rice and 2 bowls of pasta. Bundle N has 8 bowls of rice and 4 bowls of pasta. So according to the definition of indifference curve, if two bundles are on the same indifference curve, then a consumer must be indifferent between them. However, the non-cessation assumption says that if a bundle contains more of at least one of the good, then it should be preferred. Non-cessation assumption will require bundle N to be preferred to bundle M because bundle M has 5 bowls of rice and 2 bowls of pasta. Bundle N has 8 bowls of rice and 4 bowls of pasta. So automatically you can see that bundle N has more of both goods. So according to the non-cessation assumption, which is more is always better, bundle N should give the consumer a higher level of satisfaction as compared to bundle M. So the two bundles should not be on the same indifference curve. So since a person cannot be simultaneously indifferent between two bundles and still prefer one to the other, as long as the non-cessation holds, an indifference curve must be downward sloping. Now that we know that upward sloping indifference curve violates the non-cessation assumption, we are going to be sticking to downward sloping indifference curve, which satisfy the 3 main assumptions that we've considered: completeness, transitivity, and non-cessation. Now let's look at the economic interpretation of the slope of the indifference curve. So the slope of the indifference curve, it shows the rate at which the consumer is willing to trade one good for another. So remember, on an indifference curve, we mentioned that if you are moving from one point to another point on the same indifference curve and you lose some of a good, then you have to get more of the other good. So in this case, if I move you from point A to point B, because you have lost some of good Y, to be on the same indifference curve, I have to give you more of X. So that moves you from this consumption of X to this consumption of X. So that is the trade-off. You are trading off between the two goods. So this trade-off is what we call the slope. The rate at which a particular consumer is willing to trade off bowls of rice, bowls of pasta, is what we call the slope of the indifference curve. So for example, if we look at a consumer named Ella, if Ella is willing to give up 4 bowls of rice for an extra bowl of pasta, then the rate at which she's willing to trade rice for pasta is -4. Now this is shown around bundle A. So in this case, around bundle A, the slope of this curve is -4. This is simply the rate at which Ella is willing to trade bowls of rice for an extra bowl of pasta. 4 is just the number of bowls of rice that Ella is willing to substitute for one extra bowl of pasta. But you can see that I have added a negative here. So we simply add the negative to represent the negative relationship that exists between the two goods. The negative of the slope of an indifference curve at any particular point is the marginal rate of substitution of rice for pasta. We can write this as marginal rate of substitution, rice for pasta. This is simply the slope of the indifference curve, representing the rate at which Ella is going to trade off rice for an extra bowl of pasta. This brings us to another assumption. This new assumption is the assumption of diminishing marginal rate of substitution. Let's look at our curve again. We see from this curve that the slope is not the same along the indifference curve. Around bundle A, Ella has more rice. So for example, we can say that Ella has 20 bowls of rice and 2 bowls of pasta. Because she has more rice than she has pasta, she may be willing to give up 4 bowls of rice for an extra bowl of pasta. If we move down the indifference curve towards point B, we can see that at this point, the bowls of rice that Ella has decreased perhaps to 5, and a bowl of pasta has increased perhaps to 7. Around bundle B, Ella has less bowls of rice, so she's willing to give up only half a bowl of rice for an additional unit of pasta. So this means that Ella's willingness to substitute rice for pasta declines as she moves down the indifference curve from the left to the right. The decline of the marginal rate of substitution as we move along the indifference curve is what is generally called a diminishing marginal rate of substitution. The implication of this is that an indifference curve with a diminishing marginal rate of substitution is bowed inwards. If you look at this U1 curve, you can see that around this point, it's bowed inward. In mathematical terms, this is also called convex to the origin. We will look at this in detail in subsequent lessons. Now, one thing to note here is that just as Ella's willingness to substitute rice for pasta decreases as she gets more pasta, which moving from the left to the right, so does her willingness to substitute pasta for rice decrease. She gets more of rice, which means she's moving from the right to the left. If we rewrite this as marginal rate of substitution of pasta for rice, this is going to mean a movement from our right to our left, which is going to imply more and more of rice and less of pasta. So this also diminishes as Ella gets more of rice and less of pasta. So typically, if we represent pasta as good X and rice as good Y, we usually write marginal rate of substitution as good Y for X, which is the trade-off of good Y to get an additional unit of X. And the same understanding can be used in the reverse case. So this is all that we have on our lesson on the marginal rate of substitution. Our next lesson will be on deriving the indifference map. If you enjoyed today's lesson, consider subscribing. Thank you.